Hi, I'm Paul. That's George. We're both from this company called Hackathon. We make these brain-sensing EEG devices called Muse. And so we had the goal of being able to identify blinks with an HTM as good as our own internal algorithm that we use to identify blinks. So the way an EEG device works is that it detects your brain signal as long as you're not moving. And if you move, like blink your eyes or something, that muscle movement overwhelms the brain signal. And so you can easily pick it out with your eyes. So we thought this would be a pretty easy test for an HTM. We're just trying to get up to speed on HTM and how it works and how to program with it. Muse data is, an EEG device is also basically a voltmeter. So it's like just a wave of data. There's 4 channels in this. We decided to try to use a single channel, which was the left ear, to try to be able to detect blinks. So first of all, I'll give you an idea of what the typical data looks like. The blue line here would be your EEG, and then the red line is our own algorithm that we use to detect blinks. So you can see a blink here, goes down, it goes up, and it goes back to normal. And that's how you can visually detect a blink. And we're hoping to use our existing algorithm to train the new HTM algorithm. So you can see all these red spikes here are our existing algorithm detecting a blink. Okay, and then, so we don't really have much to show except, oh, it's done. Okay, so the biggest problem we had was to try to get the data small enough so that we could actually process the data in time to do something useful. So we kept shrinking down the input data because Muse samples at 220 hertz per second. And so we downsampled to average over 10 samples. And this is on the left side is the HTM predicting whether you blinked, and on the right side is our existing algorithm. Oh, it's vice versa? Okay. Reverse what I just said. So this is HTM, this is our existing algorithm. So it seems to be doing pretty well. It's only mispredicting occasionally. So here we have some mispredictions, but most of the time it seems to be working pretty well. Yeah, so that's what we got. Do you want to add anything? Yeah, any questions?
Yeah, well,
Go ahead.
Do you have instances where the HTM predicted something? Oh, I'm looking at it, sorry.
Yeah.
Next one.
Yeah, okay.
well, when you have 3 predictions of a blink in a row, how far apart are those separated in time?
Yeah, that's a single blink, right?
But you were saying that in this case, you say, well, we missed a couple, the HTM missed a couple, but if it's a single blink, it didn't really miss it.
Exactly, you're right. There's only one instance where it completely went wrong. Where is it? Yeah, there was one instance where it mispredicted.
And how are you making the prediction with the HTM? I mean, it builds a temporal model of the data, but what are you doing what exactly are you doing to make the prediction then?
Figuring it the way you recommend.
Are you using our prediction? What do we have in it?
This is a classification task.
Yeah.
So it's not really a prediction task.
I'm just wondering.
I'm trying to figure out how you set up.
Okay, so yeah, we talked about, internally we talked about whether to use prediction or anomaly detection or what. Since it's a binary value, like you blinked or you didn't blink, it kind of can fit into prediction because you base it on the EEG data and you predict basically, because we had a way to classify the links already. It didn't have to,
So
we didn't have to figure that out.
Like, I guess.
We had labeled data. already.
What does the file look like that you're feeding into the HTM if you're doing
Okay.
prediction?
It looks like this. So we have voltages, and then whether a blink happened.
And both are being fed. So both of those are being fed into the HTM, and it's predicting the next time step?
Exactly, yeah.
Right value is the predicted value and the left value is.
Okay. So the right column is also being fed into the HTM.
The right column is what it's supposed to be using to predict the
The
left.
next-
Sorry, the left column is supposed to be using to predict the right column.
Yeah, but it doesn't sound like it's set up that way.
It is that maybe our output doesn't
Okay.
show it, but it is set up that way. We think.
Okay, because we don't have an existing code sample that does that. So that's why I'm curious how you set it up that way.
Well, we talked to a lot of
Okay,
people.
we can
in
talk.
here.
We can
Yeah.
talk offline. No, I understand the task.
Okay.
You're trying to predict
Yeah.
one field given another. Not to predict forward in time.
Code samples feed both fields into the HTM, so it might be doing something really trivial, which is taking the current
The identity function or something like that.
and ignoring the DG data.
Yeah.
Show the numbers.
These?
So, bit different interpretation of what this is showing from my understanding. So here we have a
Can you
current
speak into the
value.
mic a little? Sorry.
Here we have a current value that the system is seeing, and here we have a potential predicted value. So this is the blink information that it's seeing, and the right column, it's what it is predicting to see. So right now it sees 1, next one it predicts to see 1 as well. Here it sees 1, predicts that there will be no blink further down.
Yeah,
Yes, it is.
for sure. That we know. Any other questions? All right, thanks.
Okay, thank you.